Hello, my dear students, and the rest of the learners. Welcome to part 24 of a 41-part series of tutorials in Fundamentals of Object-Oriented Programming in Java. In this tutorial, we are going to be looking at methods and parameters with our focus being on what we call the inbuilt methods. My name is MemJM, or you can simply call me Emily Swap. What is a method? A method is what we also call a function. It is a block of code which only runs when it is called to perform certain actions. We thus communicate with objects using methods. Methods are thus used to reuse code, define the code once, and use it many times. Therefore, we have two categories of methods in Java, and these are the inbuilt methods and the user-defined methods. My dear students and the rest of the learners, based from the previous presentation this series, you remember that we said that when you have a large program that is supposed to perform several tasks or many tasks, it is advisable that you break down that large program into portions whereby each portion performs a single activity. And therefore, when we speak about methods in Java, we are simply speaking about that section of code which performs a single function or which performs a single task. It is important to always break down a large program into its respective portions, modules, or subroutines, whereby each subroutine performs a single task. And therefore, a method is that subroutine that is used to perform a single activity. And therefore, if you have a program that performs many activities or performs several activities, then it is advisable that each of those activities is coded separately as a subprogram, but within the main program. And then you join those subprograms or you link them to form the large program. And those portions of code are executed in the order of arrangement or in the order that you want to use. Because if one method is supposed to generate data that is used to be used by another method, then that method that is supposed to generate data is supposed to be executed first, and then the one that will rely on the data that will be produced by the other previous method is supposed to follow. And therefore, that is simply what we call methods, or that is the idea behind methods in Java. And therefore, we are saying that there are two types of methods. Now, these methods are one, what we call the inbuilt methods, and what we call the user-defined methods. So, what is an inbuilt method? An inbuilt method is also called a standard library or what we call the inbuilt method. So, inbuilt or standard library methods are those which are predefined within the compiler or within the processor or within the programming language. And therefore, these are predefined block of code within the programming language that is invoked to perform a particular action. They are defined in a certain header files, which are included in the Java source code whenever the functions in those header files will be needed in the program. Examples of such code or such methods include the iterator methods that are used to access and iterate through collections, such as next, remove, amongst others. My dear students and the rest of the learners, note how we write or how we indicate a method. It is the name of the method followed by a pair or parenthesis. The second type are what we call the scanner methods that are used for inputting data. Examples of such are the close method, next line method, amongst others that we are going to learn within this presentation and in this series of presentations on programming using Java. The third type is what we call the array methods, which are used for handling arrays such as compare, sort, amongst others. The fourth type are what we call the output methods that are used for displaying or writing out data such as print, print line, amongst others. The fifth type is what we call math methods that are used for performing various mathematical operations such as absolute or ABS, a square root, amongst others. The java.lang.math class provides many common mathematical functions that will prove useful in performing numerical computations. It is thus important that whenever you are going to use inbuilt functions or inbuilt methods within your code, that we include the java.lang.math class as part of your code. And therefore, my dear students and the rest of the learners, these types of code or these inbuilt functions make it easier for you to apply certain functions that may require a lot of time if you are coding them one at a time. As an element of the java.lang package, it is included implicitly in on Java programs, just as I have said. The Java's math class cannot be instantiated and cannot be subclassed. By declaring the math class public final, we indicate that it can be accessed. That is, it is public, but it cannot be extended or subclassed. That is final. By declaring its default constructor to be private, we prevent this class from being instantiated. The idea of a class that cannot be subclassed and cannot be instantiated may seem a little strange at first. The justification for it here is that it produces or it provides a convenient and efficient way to introduce error-proof math functions into the Java language. Defining the math class in this way makes it easy to use its methods because you don't have to create an instance of it. It is also a very efficient design because its methods are static elements of the java.lang package. This means they are loaded into memory at the beginning of your program's execution and they persist in memory throughout your program's lifetime. Because math class methods do not have to be loaded into memory each time they are invoked, their execution time will improve dramatically. The following is a description of some of the inbuilt methods or inbuilt class methods that you can invoke to perform a particular action in Java. So we have method, description, and example. For example, int absolute within the parentheses of the parameter being x of type integer. This is an absolute value of a variable, like in this case, the statement is being used to compute the absolute value of the variable or the parameter or the argument within the parentheses. An example is, if you have it as x is greater or equals to 0, and then you write it as absolute or ABS x, then what you get is x. If you have it, for example, a situation where x is less than 0, and then you compute its absolute value, then what you get will be negative x. And therefore, these methods can be declared using statements like int absolute, then within parameter you have x of type integer, long absolute, then long x, float absolute, then float x. So in other words, you can compute absolute values for integers or the reals, numbers which are large, numbers which also have decimal points. Another method is seal. A seal. Now, whenever you want to round the value or a value to its nearest or smallest integer that is not less than that value, then we use the method seal. And therefore, we can declare it or we can write it as int seal and then double x. Simply, what this does is it rounds the value you have given that has decimal points to the smallest integer that is not less than that value, which is enclosed within the parentheses, or that is being passed to the method called seal. Example is seal, and then we are passing to that function value 8.3. And therefore, the answer which is returned is 9. If you have value negative 8.3 being passed to the function called seal, the function called seal will return negative 8. Another function or another method is called floor. If you pass to floor or this function a value which is x, value x of type double, and then, or what we get, or what it does, is that it will round the value you have passed to the largest integer, but an integer which is not greater than the value itself. For example, if we pass 8.9 to the method called floor, it will return value 8. But if we pass to the method called floor, negative 8.9, the value which will be returned will be negative 9. And you can see the value being returned is of type integer. Another method is log. Log. It is used to compute the natural algorithm or the natural logarithm of a value. For example, the natural logarithm of x. If you want to compute the logarithm of x, then what we do is that we pass the value of type double, that is a value of type double, for example, value x, to the method called log. And you can see this method will return a value which is of type double. Therefore, if, for example, we pass to 8, 2.718282, if we pass 2.718282 to the method called log, then the value that is going to return is 1.0, which is of type double. We have a method called power. Power. Power, if you pass to 8, a value raised to a certain value. Note, when you use the method called power, you are supposed to pass to 8 two values. One is the value that you want to be raised, and then being raised to what? So the value and the power. For example, you can raise value x to power y. So value x is of type double, and the value y is of type double. And therefore, if, for example, we want to pass value 3 raised to power 4, we write it as power. Then within the bracket or within the parentheses, we put the value which we want to raise and the power we want to raise is 2, or the value by which we want to raise it. For example, 3 raised to power 4. We write it as power, then 3, 4. Now, if we pass value 3 raised to power 4, it is going to return 81.0. Why 81.0? It is because the value which we want to be returned is of type double. Therefore, it is 81.0. If we pass, for example, value 16.0 raised to power 0.5, then the value which will be returned will be value 4.0. We can also use a method that is able to generate a random number within a certain interval, and therefore we need to specify that interval. For example, 0, 1. And therefore, if we pass, or if we have value 0.1, or if we use the method random, if you use the method random within our code, random is going to generate a random value. Every time you execute the method called random, it is going to generate a different value each and every time because it generates a random number. And therefore, generally, we don't need to pass a value to the method called random. We just need to write it syntactically right within our code to indicate that we want to use a method called random. So the method called random generates a value at random. For example, in round 1, it will generate 0.5551. If you run it again, it will generate 0.8712, etc. No, these values will vary. It's not a must that when you execute a statement, that is implementing random method that it will generate my value. It depends with the value that will be generated. Note, it generates random values. Another method is round. Now, round rounds a value to an integer. So, if you pass, for example, to 8, a value of type double, for example, value x of type double, for example, round 26.51. If you pass 26.51 to the function or to the method called round, it is going to generate value 27. If you pass to 8, a value like 26.499, it is going to generate value 26. Note, if a decimal point or the fractional part is beyond 0.5 or is 0.5, it will be rounded the nearest number. For example, 26.51 is rounded 27, but if it is less than 0.5, it is rounded to, for example, 26. We can also use the method called square root. Square root is used to compute square roots of a number. So if, for example, you pass to 8, a value like 4.0, which is of type double, it will generate a square root of 2.0. Another method is absolute. It returns the absolute value of a variable. And those types returned or absolute method can return values of type double, type float, type integer, or type long. We have a cos. A cos returns the cosine of a variable in radians. So if you pass to it, for example, value x, it will generate or return a value of type double. Another method is and exact. And exact, my dear students, note, you write it exactly as I have written. Where there is uppercase, ensure you have uppercase. For example, E for exact is 1. So if you pass to unexact, a variable or variable like x and y, or two values, value x and value y, what that method will do is that it will return the sum of those two values. For example, value x and value y. So the data or the value returned can be of type integer or type long. You just need to specify in advance whether you want to use that method to return an integer or to return long. Another method is assign. Assign. So if you pass to it a variable, for example, a variable of x, a variable x, it is going to return the arcsign of that variable, but in radians. And therefore, it returns value of type double. Method attend. Method attend returns the arctangent of x, that is arctangent of variable as a numeric value, which is between negative p or pi or pi divided by 2 and pi divided by 2 radians. So the value returned will be of type double. The method attend to. When you pass values to it, for example, two values like x and y, what you are passing to it is simply the coordinates. Therefore, it returns the angle theta from the conversion of rectangular coordinates of x and y to polar coordinates, r and theta. So the type of value it returns is of type double. We have CEL. We are going to talk about the CEL. When you pass a value to the method called CEL, it returns the value of that variable but rounded up to its nearest integer. And the value which is returned is of type double. If you have a method called copySign and you pass to it two values, for example, x and y, it is going to return the first floating point of the first variable with the sign of the second floating point, y. And therefore, it can return data of type double or type float. Cos, if you pass a variable to cos, or a value to cos, it will return the cosine of that value or that variable. So x is usually in radians. The data type it will return is a type double. Cosh is a method which, when you pass a value to it will return the hyperbolic cosine of a double value. Therefore, the type of data it returns is type double. We have decrement exact. If you pass a value to decrement exact method, it will return that variable subtracted 1. So the type of value it will return is of type integer or type long. Exp or exp, that is exponential of a variable. If you pass value, for example, value x to the exponential method, it will return the value of that value, or it will return the exponential portion of the value, which is e raised to power x. So type of value it will return is of type double. We have exponential m1. If you pass a value to it, for example, value x, it will return e raised to x subtracted 1. And the value type that it will return is of type double. We have floor. Floor, if you pass a value to 8, which, for example, as a decimal fraction, it will return the value of that variable or that value, but rounded down to its nearest integer. So it can return data of type double. Method floor diff. Floor diff, if you pass two values into 8, or to 8, like value x and y, it will return the deviation between the first value and the second value, rounded down. So it will return a value of type integer or even type long. Floor mode. Floor mode, if you pass two values to floor mode, where you have the first value being x and the second value being y, it will return the remainder of a deviation between the first value and the second value, where the result of the division will be rounded down. So it will return data of type integer or type long. Get exponent. If you pass a value to the method called get exponent, for example, value x, it will return the unbiased exponent that is used in the value x. So the data it will return is of type integer. We have hypot. If you pass two values to the method called hypot, value x and y, it will return the square root of the first value squared plus the second value squared without intermediate overflow or underflow. So it will return value which is of type double. We have the IEEE remainder. If you pass two values, value x and value y, to the method called IEEE remainder, it will compute the remainder operation on the first value and the second value as prescribed. Therefore, my dear students and the rest of the learners, we have very many other methods that are inbuilt. What is important is for you to be able to know the work that each of the methods does and how we pass parameters into it and the type of data that is returned. We have like log 1p that returns the natural logarithm of the sum of value at 1. We have the max, which is written in that format and returning the values, type of values indicated. We have the mean. We have the multiply exact. We have negate exact. We have next exact or next after. We have net down method, next up method, power method, the random method, the int method, round method, scalp, signum, sign, sign h, that returns the hyperbolic sign of n double value. We have the square root that returns the square root of x. We have subtract x that returns the result of x minus y. We have tan x that returns the tangent of an angle. Tan h returns the hyperbolic tangent of a double value. 2 degrees converts an angle measured in radians to an approximate value that is equivalent angle measured in degrees. We have to int exact that converts a long value to an integer. We have to radians that converts an angle measured in degrees to an approximate angle measured in radians. We have alp returns the size of the unit of least precision of a value. And therefore, whereas we have many inbuilt methods, what is important is to know how to invoke an inbuilt function within your source code by, for example, writing it as follows. The name of the file, month, then followed by dot method name, month dot method name. For example, the method for computing square root of a number can be written as month dot square root. Then you enclose the value whose square root will compute within the parentheses. In other words, you are passing a value to the method called square root that is found in the file, in the library file called month. For example, if you want to find the square root of a value 4.0, we pass 4.0 to the square root method that is found within the month file as follows: month.sqrt. Then we enclose 4.0 in the parentheses. My dear students and the rest of the learners, can note that month is written in the syntax indicated. Letter M or letter M is usually written in uppercase. The following, therefore, is a sample program implementing some inbuilt methods that you can use to compute the square root of a number. Round it up, round it down, and raise it to a predefined or to a specified power. So this is my program. And you can code this program within your Java. For example, using Eclipse or NetBeans or any other. So I'm going to use NetBeans to code my Java program that implements inbuilt methods. So the first statement is a comment. The comment is program implementing an inbuilt method such as, or inbuilt methods such as square root, round, fill, floor, and the power of a number. The name of my package is inbuilt. Then we have the statement import java.atil.scanner that tells the compiler to use a scanner class from the package. We have public class inbuilt. Note, the name of the class is generated while in the process of setting up your program. Also the name of the package. So the name of the package or the package statement, this statement, and this statement will be generated based on the name you give to your package, the name you give to your project, and the name you give to your class. Then under the public class inbuilt, we have the main method, which is public static void main, followed by those parameters, as you can see. And then its definition is we are declaring the following variables of type double: num, square root, lower value, upper val, round val, raised val. Remember, these are just names that I'm using for my variables, and it's going to ensure that they are meaningful, just as I have been saying throughout this series of tutorials. Then I have another variable called raising val. This of type integer. Then the next statement is to define an object that we're going to use when reading our values. So this object is input. Input is of type scanner, and we are defining new scanner. So you write it as a scanner, input equals to new scanner, and you enclose within it system.in. The syntax is key. Then the next statement is sign system.out.println. So the statement enter a number that you would like to make computations for will be displayed on the screen, and the cursor will be moved to the next line. And therefore, from there, we enter a value. You enter a value, and this value is of type double. So it's a number with a decimal point. And therefore, that number will be read using the method next double, or the method for reading the value of type double through the object called input, and that value will be assigned in memory location called num. Then from there, we compute the square root of the num, or the value in the memory location called num. How do we compute the square root? We pass the variable num to the method called square root. So we write it as math.square root, and we enclose the name of the variable that contains our value, whose square root we want to compute within the parentheses, and the answer, or the value that will be returned, is assigned into the memory location called the square root. From there, we display the value through the statement, the square root for the content of memory location called num is, then the compiler picks, or the processor picks, the value in the memory location called the square root. So if, for example, you have entered the number being 4, and the square root, for example, which is generated as 2.0, then the statement will read, the square root for 4 is 2.0. That's just an example. From there, we can round the value we have gotten, the value in the memory location called the square root. We can round it, and then we store the response or the answer into the memory location called rounded val. From there, we display the value that has been rounded using the statement, the value of, we pick what is in the memory location called the square root. For example, if what is in memory location called square root is 2.0, then the statement will be displayed as the value of 2.0 rounded to its nearest integer is, so the processor will pick the value from the memory location called rounded val and display it here. So the answer will be, for example, the value of 2.0 rounded to its nearest integer is, for example, 2. If, for example, you had the value of the square root being 2.6, then the statement will look as the value of 2.6 rounded to its nearest integer is now 2.6 rounded. So the value is what will be displayed here. Then we can display the statement, you would like to raise. You would like to raise the content in the memory location called rounded val by which value? So if you want to raise the rounded value to a certain figure, for example, 2.0 raised to 4, then you can enter that value 4 After this statement is displayed, you can type 4. Now, that value 4 is supposed to be of type integer. So it will be read by the method, or that value will be read by the method for reading integer, which is next int, through the object called input. So that value will be read and it will be stored in the memory location called raising val. Once we have done, or once our value, or once we have a value that we want to raise our value to, stored in the memory location called raised val, then we can use the method power as follows. Math.power, then we enclose in the parentheses the value that we want to raise and the power we want to raise is with. For example, if you have rounded value being 5 and you want to raise it to power 6, then we are going to enclose 5, 6, meaning that 6 is the value that has been stored in memory location called raising val, while 5 is the value in the memory location called rounded val. Then the answer that will be returned will be assigned in the memory location called raised val. And therefore, if you want to display the statement on the screen, the value of, we pick what is in the memory location called rounded val. We display it here, raised to the power of. The compiler will pick the content in memory location called raising val. Is it will pick the value in the memory location called raised val. And therefore, what we are going to have in the positions for rounded val, raising val, and raised val are the values that are in those specific memory locations. For example, if you have in rounded val, we have 4. In raising val, we have 5. And raised val, we have 50. It will read as the value of 4 raised to the power of 5 is 50. Remember, I'm just giving an example. The exact values are the values that have been computed and stored in the various memory locations. We can also find or compute the ceiling of the value in the memory location called square root. You remember the work of ceil. If you want to round the value in the memory location called square root, as explained using the method ceil, we write it as follows, and then the value which will be returned can be stored in a memory location called, for example, called upper val. And therefore, we can be able to display the content in the memory location called upper val and the content in the square root variable. For example, the value of 2.0 rounded up its nearest integer is the value 2.0 that has been rounded, or the response, the answer, will be displayed. We can also round using the method floor. And this is how we write it. This simply means that we are rounding the value of square root. Now the question is, remember, ceil and the floor are all rounding, but one raises up, the other one raises down. I hope you remember what we have said concerning floor and concerning ceil. And we have also looked at another method that is called round. So the answer that will be generated will be stored in the memory location called lower val. And therefore, we can display this statement, or this statement will be displayed on the screen. The value of the content in memory location called square root will be displayed here. Rounded down to its nearest integer is, we pick the content in the memory location called lower val and display it at this point. We are going to see how those numbers will behave once we code this program again, or once we execute it in Java through the Eclipse IDE. So let's code this program. Let's code this program using Eclipse IDE so that we can see when the way I've explained it is the way it will behave. So we are going to launch our Eclipse IDE. So we just search for it Eclipse IDE. Remember, you start this program in the same way you load other programs. By now, if you have been practicing or you've been following my series of tutorials, I believe that you are now familiar with how we write our programs in our, or how we code our Java programs using the IDE that we call Eclipse. So once you have launched Eclipse, you proceed as follows. So once you're here, you click on File, point on New, then click Java Project. Then we give our project a name. Remember, the name should be one that is self-explanatory. So I'll call it Inbuilt. I'll call my project Inbuilt. And note, you can see here, discouraged module name. By convention, module names usually start with a lower case letter. So you have to write in lowercase. For example, Inbuilt. From there, you can skip the rest and you click on Finish. Once you are here, you right-click on the name of your project and then point on New and click on Class. You can see the name of the package has already been provided. It is the same as the name of the project. So what we need to give now is the name of our class. As I have always said, ensure that the name of the class is always similar to the name or is similar to the name of your file. The name of your class should be the same as the name of your file. So we are going to call it Inbuilt, and here you begin with uppercase, Inbuilt. Then you can choose the method stub public static void main. Then from there, you can click modifiers. Under modifiers, let it remain as public. Then you can click on a finish. My dear students and the rest of the learners, you can see that once you click on finish, the name of the package has been added, or that statement has been added. The name of the class Inbuilt has been added, and public static void main has been added. So you can type your code here, but remember that before that, you need to type the statement here for import java dot atil dot scanner. Never forget that statement. Import java.atil.scanner. From there, you can proceed. You can even add your comment. You can always add your comment, for example, on top here. You can type your comment here. But for now, let me not bother with the comment. So my main interest is on this section. So here, you have to type the rest of your code. You don't bother with the rest of the parts. So you just type your code here. Note that the name of your class Inbuilt is the same as the name of the file. You can see on top here, it is inbuilt.java. Those must always match, regardless of whether you're using Eclipse or whether you are using NetBeans. So my dear students and the rest of the learners, you can type your code here. But if you have typed it, for example, using a word processor, like Word, and you have tried to debug it from there, or you have gone through your code, and it's okay, like the one we have discussed, you can just copy and paste your code here. So because I have already discussed each of the parts in my program, I'm going to simply paste my program here that we have already discussed. So what I'll do is let me paste my code here for the program that we have already discussed. This is the program. You can see this is the program that we have already discussed. So I've just copied and pasted my program here in the same format that we have discussed. So you can see we have our declarations here, we have our scanner statement here, and we have the rest of the statements here. So once you have your program, once you have coded or typed your code, you can always remember, or you should always remember to save your source file. Then from there, we can run it. So you click on run, and then I'll click run. You can see that my program has no errors, and already the first statement here, this one, has been displayed. Enter a number that you would like to make computations for. So my number can be, for example, 9. So you type, or 8. So you type 8 and press enter. You can see after you have typed value 8, it has been read and stored in num. Then from there, the value in num has been computed square root 4, and that value has been stored in the memory location we call the square root. So here, under system.out.println, you can see the next statement is the square root 4, 8, the square root 4, 8.0 is 2.82842712474619003. This one. Then that value, this value, is being rounded to its nearest integer using the method round. And therefore, you can see the value of this number rounded to its nearest integer is this. So this is the statement. So this value, 3.0, is the value that is in rounded var. While this value here is the value in the square root variable. From there, you can see you would like to raise this value by what value? So you would like to raise 3.0 by which value? So we are going to enter a value which will be read and stored in the same value. So we want to raise it to 5. So type value 5 and press enter. And see, once that has been done, 5 or this number 3.0, this the power of 5 is, this is the value. So this is this statement here. So the value is raised and the answer 243.0 has been stored here. So this statement will display the message, the value in the rounded var, the value of this figure rounded to its nearest integer is, we pick the value in raised var. Then the next, the value of rounded to its nearest integer. So remember, this is the first statement. Then we have the value of this rounded to its nearest integer. That is this statement here. And then we compute again the value, or we round the value we have to its nearest integer, rounded down. And therefore, that is this statement here. And with that, my dear students and the rest of the learners, this is a program that is implementing a number of inbuilt methods. So you can always close or end the task once you are done. You can close or end the task, and you can also exit. You can exit from the program. So we can click on the file, and then we click exit. And we go back to our presentation. And therefore, my dear students and the rest of the learners, that brings us to the end of part 24 in the 41 part series. You can now proceed, listen, watch, and practice part 25 of the 41 part series, in which you are going to learn about the string methods. Congratulations for learning part 24 of 41 part series on inbuilt methods in fundamentals of object-oriented programming using Java. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. Remember, you can join Emily Swap ICT as a special member through the join button, where you'll be able to enjoy additional privileges and additional services from the channel. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part of the series, and God bless.